And also, like I said, 9.6, solving equations. All right, so we're going to start out by solving exponential. And y'all, exponential equations come in this form. Y equals A to the X. And we're going to be solving for these variables here. So now the exponent is the variable on these equations, okay? So let me write my steps and then we'll start solving these. So the first step, if possible. Y'all, if it's possible, the first step you want to do is to try and rewrite each side of the equation using the same base. So we want to rewrite each side of the equation um, using the same base. Now, the reason I would like to get each side written with the same base is because I can then invoke what we call the base exponent property. So this base exponent property tells me if a to the x equals a to the y. So if two sides are equal and they got the same base, that means the exponents have to be equal. So x has to equal y. All right, so if possible, I would like to rewrite each side of the equation. But y'all, it might not be possible to do that. So if it's not possible to rewrite each side using the same base, then I got to go another route. So the first thing I would do is I would take a log. So take a log or ln of both sides. And that goes back to what I do to one side of an equal sign, I gotta do on the other side of that equal sign, okay? Now, the reason I want to take a log or ln of both sides is because then I can invoke the power rule and bring the exponents down to the front like we did the other day. So using the power rule, bring the exponents down and write as a product. But what that does is that brings that exponent down, so then I can start working to solve it, okay? All right, at that point, no matter which way I went, I either rewrote them or I had to do the logs to them. At that point, we would solve for the variable. Okay, so when I solve for the barrel, I want that x on one side, everything else on the other. And y'all, then my last step on these equations is to check my answers if needed. All right, that's what you do on any equation. Check those answers by plugging the numbers back into the equation and seeing if you get a true answer or not, okay? All right, y'all, so that's what we're going to be doing, following these steps, running through these. So for these examples, they're going to say solve for x. All right, y'all, so my first one, I'm going to have 6 to the x equals 36. So here would be the question. I got a base 6 on the left side. So my question would be, can I rewrite 36 as 6 raised to an exponent? Is that possible? So Tiffany, good job. That'd be an exponent of 2. So what I'm going to do is rewrite 36 as 6 squared. So rewrite 36 as 6 squared. So that one we could actually do that. So now, if you notice, the bases match. So since these bases match, we're invoking the base exponent property that says if these bases match, then x has to equal y. Well, I got my x has to equal 2. And so that one I'm done. So if I want to check this, I'll put my 2 in for the x. 6 squared equals 36. That is a true statement, so we did good. All right, y'all, so let me change it up. And let's try this one. We're going to solve for x. So y'all, this one has 5 to the x equals 24. So the question would be if we could rewrite 24 using 5 raised to an exponent. You know, that's not happening, right? Because 5 to the first power is 5. 5 squared is 25. So there's no way to equal 24 by using 5 for the base. So this one we cannot rewrite 24. Using the 5 as the base. So since I can't rewrite the 24, right here it says if it's not possible, we're going to take a log or ln of both sides. So here's what I do. I do a ln only if I got that e in the problem. That Euler's number we've been learning about. If I got that in there, I use the ln. But since I don't have the e here, I'm just going to take a log of both sides. So that's going to give me a log of 5 to the x equals a log of 24. So here I just took the log of both sides. Now, y'all, the whole reason I did that was because those problems the other day when we were simplifying, the power rule of exponents says that if I got an exponent, I can bring the exponent down to the front and rewrite it as a product. So that this side will give me an x times the log of 5 equals the log of 24. All right, so you got to get the exponent brought down so you can actually solve for that variable. Now, the only step I got to do to get this x by itself, I'm going to divide both sides by log 5. So I got an x times log 5 divided by log 5 is going to equal a log 24 divided by log 5. Now, in your calculator, when you do this, you want to close those parentheses around those logs, okay? And on the ones where you got to do the logs, you're going to have to round them out 4 decimal places. So let me go to my calculator and let's see what we get on this. So y'all got my alpha y equals. I'm going to hit alpha y equals so I can make it look like a fraction and hit enter. On top, I got a log of 24. All right, close those parentheses. On the bottom, I had a log of 5. Close those parentheses. So now we got what we need. We're going to round this off 4 decimal places. So it looks like I'm getting a 1.974. All right, the 6 has a 3 after it, so I'm going to leave that as 6. So that's going to give us a 1.9746. Okay, so that's your trick on that. If you got to do the log stuff, remember to close those parentheses on each log when you put those numbers in, okay? So, y'all, that's the 2 things we're doing. We're either going to rewrite them using the same basis, or we're going to be forced into using the logs or the ln, okay? All right, y'all got any questions on those 2? All right, y'all, let's move on. All right, so for my next one, y'all, same thing. Solve for x. So on this one, I'm giving 3 to the 9x minus 5. That's going to equal 81. All right, y'all, so my first question. Can we rewrite 81 using 3 as a base? Good job, Tiffany. We definitely can. And actually, so let me write down the 3 to the 9x minus 5. And actually, that'll be 3, what you got there, to the 4th power. Good job. So you want to rewrite the 81 as 3 to the 4th. So y'all look what that does. That means these bases now match. Since my bases match using the base exponent property, that means that the 9x minus 5 has to equal the 4. All right, so the exponent has to equal that exponent. So now solve for x. So this one, we would get the 9x by itself. So we would move the minus 5 by adding 5. All right, y'all, let's see. The 5's cancel. That leaves me a 9x on the left side. And then 4 plus 5 gives me a 9 on the right side. All right, y'all, then my final step, divide both sides by 9. So that's going to give me 1x, and then 9 divided by 9 gives me a 1. So if I put a 1 in here, 9 times 1 is 9. 9 minus 5 is 4. And 3 to the fourth power equals 81. So y'all, they definitely will check out if you plug those numbers back in, okay? All right, y'all, this number 6 is a tricky one. Number 6, the one I'm about to do is like number 6, and it's a really tricky one. So let's go. I got 10 to the negative x equals 8 to the 5x. Now, I think everyone I've seen had 10 to the negative x on the left side. What they were changing were the 8s and the 5s here. But y'all check this out. You got two different bases, and the variable is the exponent on both sides. There's only one exponent that I could raise different bases to and give me the same answer. So let's solve it and we will see what that exponent is, okay? Now, y'all, the first thing I'm saying on this one, I'm not going to try to rewrite these using the same bases. 8 and 10, there's no way to do that, okay? So, so I cannot rewrite these using the same base. I'm going to take a log of both sides. So I got log of 10 to the negative x equals log of 8 to the 5x. Now, y'all, this side, you remember there's not a number by this log for the base. So when a log don't have a number here, remember, this is really a log base 10, and so is this one. But y'all, I'm not worried about this side. Look at this side. You got a log of a base 10, and that base is raised to an exponent. What is that left side going to equal? And I gave y'all a little property last on Tuesday. So I'm going to recall y'all for a second. So recall, I said if you had a log of a base A of A to the X, what did that equal?
I forgot.
All righty. So remember, so if the base of the log matches the base raised to an exponent, it always equaled the exponent.
Oh, okay.
So notice this side, you got a base of a 10, and then that 10's raised to an exponent. So the left side is just going to equal a negative x. Now the right side, I'm going to bring down that 5x so that I get a 5x times a log 8. All right, so my next step, I got an x on this side, an x on this side. I'm going to get all the x's on one side. So since this one's negative, I'm actually going to add x to both sides. So negative x and x over here give me a 0. I do not have any like terms, so I'm just going to write 5x times log 8 plus x. All right, y'all, so this next part is sort of tricky, but here's what you would do anytime you got the variable in two different terms like this. Because I need to pull that x out somehow. So how I'm going to pull that x out is I'm going to pull the x out like a greatest common factor. So that'll pull out the x. So if you factor out the x like a greatest common factor, what's left is a 5 times log 8. And in here, x divided by x leaves us a 1. So y'all are going to be really close. The only difference on y'all's and mine is the 5s and the 8s I got, okay? Now, I need to make that a 1x, so I'm going to divide both sides by the parentheses. So I'm going to have 0 divided by the parentheses, 5 log 8 plus 1. That'll equal the right side divided by the 5 log 8 plus 1. So notice these parentheses now cancel, leaving the x. And y'all look at that. 0 divided by anything is a big 0. So if you got the variable on both sides of different bases like this, the only exponent that makes that work is a 0, because 10 to the 0 equals 1. 8 to the 0 equals 1. Okay, so remember that, y'all. 0 is a magical exponent because it can turn any base into a 1, okay? Now, y'all, here we go again. Solve for t. So I don't have an x this time. I got a t, actually. Now, this one gives me a e to the t equals 153. All right, so I'm not going to try to rewrite that 151 using e as a base. So since I cannot rewrite this one, look here, I got an e. So remember, I said if I had an e, I'm going to take ln of both sides. Okay, so I'm going to do the ln of e to the t equals the ln of 153. Now, remember, ln is really a log base e. So this side is really a log base e of e to the t. So what's going to be left on my left side? So remember, that's a log base e of e to the t. So that follows that little property I put up here a while ago. The base of my log matches the base raised to an exponent. So y'all, this left side, ln of e to the t, no matter what exponent is here, it's always going to equal the exponent. And then the right side is going to stay at ln of 153. So since we got an ln on this one, we're going to go to the calculator and round that 4 decimal places. So y'all, let's pull up our calculator. So I'm going to pull that out 4 decimal places. So ln is on the front. And then let's put in our 153 and enter. And we're getting a 5.03. Oh, let's see. Do we want to keep the 4? Yeah, because after the 4 is a 3, which is less than 5. So we're going to keep that a 4. So 5.0304. Hey, also, that's what I would put into Math Lab. All right, question on that. All right, y'all, so let me do one more exponential and then we'll get into doing the logarithmic ones, okay? All right, y'all, so this one I got 6 to the x equals 3 to the x plus 1. Now on this one, I'm not going to get zeros because you can make this a 0, but over here, 0 plus 1 would give me a 1. So since you got that plus 1 on that one, this answer will not be 0, okay? Now this one's a little tricky too, but I cannot rewrite these using the same base, so I'm going to take a log of both sides. All right, so that's going to give us a log of 6 to the x equals, now here you got to be careful, okay? Because on this side, we got to apply the log to both of these exponents, okay? So I'm going to start out doing this, log 3x plus 1. Now, here's the tricky part. Right here, you're going to bring down the x. And this side will give you an x times a log 6. Over here, you got to bring down both exponents and sort of distribute them through, okay? So you're going to bring the x down first times the log 3. But then you got to bring the 1 down times the log 3. So you have your plus, and then 1 times log 3 is just a log 3. But y'all remember that still technically has a 1 in front of it, okay? So it sort of goes back to what I had a while ago. Um, Up here where I had to get the x's on one side, I got an x over here and an x over here. So let's move these x's to the left side. And y'all, to do that, we're going to subtract x log 3 from both sides. So these are not like terms. So we're going to have an x log 6 minus an x log 3. And on the right side, those cancel. So all that's left is the log 3. Okay, so let's think about this. We got the x in both of these terms. We want to turn those two x's into one x. So y'all, what we're going to do again, we're going to factor out the x like a greatest common factor, like we did up here. Remember, anytime you got the x in two spots, you got to factor it out like a GCF. So that'll give me x times log 6 minus, if you take this x out, all that's left is log 3. And that's going to equal the right side, which is a log 3. All right, so up here, when I had the x times the parentheses, I divided both sides by the parentheses. Here, I got the x by the parentheses. I'm going to divide both sides by the parentheses. So x times log 6 minus log 3 divided by log 6 minus log 3 will equal a log 3 divided by log 6 minus log 3. See, all this is going to cancel out on your left side, leaving the x. This, we're going to punch in on the calculator. Now remember, we got to shut all these parentheses around our logs, okay? So let me show you how we would punch that one in. And we're going to round it 4 decimal spots, okay? All right, so y'all, the first thing we'll do is hit alpha y equals and enter to make it look like a fraction. On top, I had a log 3, close parentheses. Then I'm going to the bottom, I had a log 6, close parentheses, minus a log 3, close parentheses. Y'all, it now looks exactly like we had on our paper. So hit enter, and then we're going to round it off 4 spots. So I got a 1.58. Okay, then a 4.9. Oh, but y'all, the 9 has a 6 after it. So I'm going to round 9 up into a 10, but that means that 49 will turn into a 50. So I get a 1.5850. All right, let's see. So in MATLAB, we would put in a 1.5850 on that answer. All right, y'all. So that was solving exponential. You're either going to rewrite them using the same base if you can, or you got to do the log and LN stuff, okay? Either way, depending on what you're given. All right, y'all. So these had a couple tricky ones, the ones where you got to divide by all them logs, okay? So logarithms to me are a little easier. So let's play with some logarithms. So remember those rules I gave y'all the other day. The product rule where I rewrote them as a sum. Quotient rule where I rewrote them as a subtraction. Power rule where I brought those exponents down, and all that fun stuff is going to be in play now, okay? So for these ones, we're going to be solving logarithmic equations. So the logarithmic equations look like this. Y equals log base A of a x. All right, so first step, if needed. This is a if needed. Combine logs on each side of the equation. Now, that's on each side of the equation. Don't add one from one side, though, to one on the other side. They got to be on the same side of the equals, okay? So what we're doing there is we're writing as a single log. So that's stuff we learned how to do Tuesday. Okay, if they were added, we wrote them as a product. If they were subtracted, we wrote them as a quotient. So now, what we got to look at, do we have a log base equal to a log base. That means on each side, you got to have a log on each side of the equals, okay? If so, so this means if we do have a log base equal to a log base, we can invoke what we call the logarithmic equality. And this is similar to the log base property from a while ago. This tells me if I got a log base A of m equal to a log base A of n, if the logs match, then that means m equals n. That makes sense. If they both have the same base and they're equal, m has to equal n, okay? So we try to get this to happen. If not, then we got to do the next few steps. I'm going to rewrite as exponential. So this is why you had to learn how to rewrite from logarithmic to exponential, okay? So we're going to rewrite these as exponential. We're then going to solve for the variable. Now, it's very important on a logarithmic equations that you check if needed. And remember one thing. We cannot take logs of negative numbers. Remember the other day when y'all took logs of negative numbers, you got answers like does not exist. So if I solve one of these logarithmic equations and I get negative answers, I'm throwing them out. I can only keep my positive answers when I plug them back into these logs, okay? See y'all? Those are the steps we're going to follow. So here we go. We're going to solve for x. So we'll sort of start out mellow and then they're going to increase as we go, okay? So y'all, the first one has log base 4 of x equals 2. So on this one, notice, I've already got a single log over here, so there's no logs that I can combine on each side. So I don't have a log base equal to a log base because I've only got one log on the left side. So what that means is we're going to rewrite it as exponential. So this one I'm going to rewrite as exponential. So my base is 4. My exponent is a 2. And 4 squared equals x. All right, y'all, so one more step is to figure out what 4 squared equals. So what y'all putting there for x? All right, Brandon, good job. That is definitely going to be 16. So if you check it, log base 4 of 16, if you punch that on the calculator, it's going to spit out a 2. Okay? And y'all, that's the trick on them. Let's see, try one like this one. It's going to say solve for x again. All right, so they're giving me a log base 6 of 4x minus 4 is going to equal 4. So y'all, it's the same as this one. You got one log equal to a number, just like this one. So what we're going to do to this is rewrite it as exponential. So your base is 6, your exponent is 4. So we get 6 to the 4th is going to equal the 4x minus 4. All right, y'all. So one of y'all with a calculator, figure out what 6 to the 4th power equals. So what y'all got? L of 1296. That sounds good. So 1296 equals 4x minus 4. And y'all, at this point, we're just solving for x. So we're going to, looks like we're going to what? Add 4 and then divide by that 4. All right, so here we go. We're going to solve for x now. So add 4 to both sides. That'll give me what, 1300 equals 4x. Uh, Divide both sides by 4. So y'all, the right side will give me an x. So Ella, if you got that calculator, do this one. 1300 divided by 4. 325. Yep, that sounds good. Final answer. All right, y'all. So single log equal to a number, rewrite it as exponential right off the bat, and then solve for those x's, okay? So let's do some now that require maybe a little bit more work. So let me let y'all write that real quick. All right, y'all. So I'm going to do some now where we got to actually combine those logs, okay? All right, so they're still going to say solve for x. All right, y'all. So this one they're giving me a log x plus a log x minus 21 equals 2. So look here. We got logs that we can combine on one side. So that was that first step. If needed, combine logs. Well, what we got to do over here, we got to write as a single log. So since they're being added, we rewrite them as a single log of a product. So bring out that log. And my product will be the x times the x minus 21. That's going to equal the right side of a 2. Now I'm actually going to go one more step, and I'm going to multiply this product out real quick. So that's going to give me a log, and I'll put it in parentheses. X times x is x squared. And then x times a negative 21 is a negative 21x. All that is going to equal 2. All right, y'all, so check this out. I now have a single log on one side equal to a number. So we're going to rewrite this as exponential. So anytime you got a log on one side equal to a number, you're going to write that as exponential. But y'all, I need y'all to figure something out for me. This log does not have a base by it. So what is the missing base for this log? Ella, that is 10 perfect. So that's going to be 10 squared is going to equal the x squared minus 21x. All right, so we figure out what this is. We know what 10 squared is 100. So that's going to equal to x squared minus 21x. So check this out. This one's quadratic. So anytime we have a quadratic type equation, we need everything on one side equal to 0. So this one is quadratic. Okay. So I need to get 100 over here and make this side a 0. So to do that, I'll subtract that 100. So here's what we get. We get a 0 over here. That's going to give me an x squared minus 21x minus 100. Now, I'm going to solve this by factoring. Y'all can solve it by quadratic formula if you want to. And in week, what was it? I think in week 5 folder, remember you got that little quadratic formula calculator website? It'll work on this also. But y'all, I'm going to solve mine by factoring. Because I got an x squared, that's an x and an x. The 100, the last number here is negative. Anytime the last number is negative, you're going to have unlike signs. One factor will be positive, one factor will be negative. Now, since the middle's negative, I do know my larger number is going to be negative, okay? Now, anytime you got unlike signs, we're going to find factors of 100 that'll subtract and give me 21. So y'all find it. Find me two numbers that'll multiply to get 100, but if you subtract those numbers, you'll get 21. So let's think about that. What'll multiply to get 100? Well, 1 and 100 work, but they don't give me 21 when I subtract them. I got 2 and 50. 2 and 50 don't subtract to give me 21. What's next, y'all? Oh, look at this. 4 and 25. 25 minus 4 is 21. So these are the factors I needed. Now, y'all, I would have kept going. You had 5 and 20, and then 10 and 10. But only one set of factors will give you 21. Now, since the middle's negative, the larger factor is negative, and then the 4 would be positive. All right, so I got it factored. Now we set each of these factors equal to 0 and solve it. All right, so y'all, the first one, I'm going to subtract 4. I get x is a negative 4. And then this one, I'll add 25. And again, x equals 25. All right, y'all, so the question of the day, what's my final answer?
Don't have to be opposite, didn't you say?
Well, these were my two answers here. If y'all did the quadratic formula or that website, it would give you these two answers. But y'all, hold on, let me go back and show y'all something. Right here when I'm checking my answers, it says what? We cannot take logs of negative numbers. Well, y'all look here.
So it'll be 25.
Yeah, one of my answers is negative. So if I put that negative in here, log of -4, you're going to get an error. You cannot do that. You got to throw away that negative answer. And y'all, the only answer is going to be the 25. So we cannot keep this negative answer. All right, y'all, so be careful to check those, okay? All righty, so notice this one we had two logs on the left side, so we made them a single log. The next one I do, they're going to throw me logs on every side, okay? So let me fix my paper. It starts bowing up on me. All righty, so this one, solve for x. Now y'all look, oh, my bad, solve for t, I meant. So make that a t there. We're solving for t on this one. So they're giving me a log base 3 of a t plus 16 minus a log base 3 of t plus 7. That's going to equal a log base 3 of a t. All right, so the right side only has one logarithm, so we're good over there. But y'all on the left side, we got to combine and rewrite this as a single log. Now, here's the thing on this one. This one's being subtracted. So since it's being subtracted, it's going to look like a quotient. So bring out that log 3. Remember, the positive factor went to the top. So that's the t plus 16. And the factor being subtracted went to the bottom, which is the t plus 7. That's going to equal the right side, which is a log base 3 of a t. So if you notice, I got a log 3 on the left side, a log 3 on the right side. So these log bases match. Since these log bases match, that means that the t plus 16 over t plus 7 is going to equal the t on the right side. All right, so I'm going to treat the right side like a fraction by putting a 1 under it. And when you got an equation, a fraction equal to a fraction, to solve this, you would cross multiply. Now I'll show you in the support. This is what the support goes over. Um, but y'all, there's a little property that says if A over B equals C over D, then A times D equals B times C. You get rid of the fractions by cross multiplying. The top of this fraction by the bottom of the second one equals the bottom of the first fraction times the top of the second. Now, I'm going to take this t plus 16 and multiply by 1. Well, that's going to give me 1 times t is t plus 1 times 16 is 16. Now, the other side will be the bottom times the top. So both of these will multiply by the t. So t times t is t squared plus 7 times t is 7t. So look what you got again. This one's quadratic because of that t squared. So since it's quadratic, I need everything on one side and a 0 over here. So we're going to subtract the t from both sides. And we're going to subtract 16 from both sides. That way over here is a big 0. All right, y'all, so let's see what we're getting over here. We got our t squared. 7t minus t leaves me 6t. And then bring down that negative 16. All right, so guess what? We now got to factor this. So t squared is a t and a t. Y'all, once again, the last number is negative. So since this 16 is negative, you're going to have unlike signs. Now, to get my numbers, this time the larger number will be positive like the middle number. But y'all, I need you to find me factors of 16 that will subtract and give me a 6. So y'all, let's see, what multiplies to get us 16? 1 times 16 don't work. What's next? 2 times 8. And then the only other way is a 4 times a 4. But look, the factors that'll subtract and give me 6 are 2 and 8. 8 will be positive like the middle. And then a 2 will be negative. So y'all look, 8 times negative 2 is negative 16. 8 and negative 2 equals 6. Okay? All right, so what we're going to do is set both these equal to 0. Now, if you notice, on all these equations, when you got to do the factoring, you're going to get one positive and one negative. Okay? So look here, for the first one, since that's plus 8, we're going to subtract 8. And I get t is a negative 8. And then the second one, to solve that, I'm going to add 2. And I get t equals a positive 2. So y'all, the question of the day, what's the final answer?
2.
There you go, because you got to kick out that negative 8. So cannot keep negative answers. Good job. So y'all, that's going to be y'all's task with these problems is a lot of these are going to end up with some quadratic stuff. So get 0 on one side and then start factoring, okay? All right, so let me try a couple more of these. All right, also this one, let's do one like this. A log base 4 x plus 1 minus a log base 4 of x is going to equal a positive 3. So the first thing we're going to do on the left side, we're going to write these two logs as a single log. Since they're being subtracted, it's going to look like a quotient. So bring out your log 4. This positive factor, the x plus 1 will go on the top. This factor being subtracted, the x will go to the bottom. And that's going to equal a positive 3. So y'all check this out. I cannot do the log base property because I don't have a log base 4 on the right side. So since I can't do the log base property, the logarithmic equality, I got to rewrite this one as exponential. So the base is 4, the exponent is 3. So 4 cubed is going to equal the x plus 1 over x. So y'all, the first thing we got to figure out, what is 4 to the third power equal? So one of y'all got a calculator, figure that one out for me. So I'm looking at 4.
64.
So 64. So this side will be 64. That's going to equal to x plus 1 over x. And y'all remember, what I'm going to do is put a 1 under that 64 again. Because I got a fraction equal to a fraction, I'm going to cross multiply this again, okay? So we'll take the 64 times the x. That's going to give us a 64x on the left side. And then I'll do the 1 times the x plus 1. Well, 1 times x is x. Plus my 1 times 1 is 1. All right, y'all. So let's see on this one. We want to get all the x's on one side and get the number by itself. So we're going to subtract this x from both sides. Now notice this one wasn't quadratic because I don't have no x squareds. So since it's not quadratic, I'm just going to solve for the x here. All right, so 64 minus 1 will leave me 63 x's. That's going to equal this right side where the x's are gone. So that's just what a 1. So we need to make that 63x look like 1x. So let's divide both sides by 63. So that'll equal to 1 over 63. So y'all those cancel, and I get x is 1 over 63. And that one I didn't get a negative answer, so I can keep what we got. All righty, so solve for x again. All right, let's see what you're giving me on this one, y'all. They're giving me a log base 3 of x plus a log base 3 of x minus 1 equals a log base 3 of 6. So y'all, the first step here, left side's got 2 logarithms. We need to rewrite these as a single log. They're being added, so since they're added, this will look like a product. So we got our log base 3, and the product will be the x times the x minus 1. All of that will equal the right side, which is a log base 3 of a 6. And now I'm going to go one more step and actually multiply this out, okay? So log base 3, let's see what we get. X times x is x squared. X times -1 is a negative x. All that will equal the right side, which is a log base 3 of a 6. So what happens since you got logs on both sides? This log base matches that log base. So the log bases match. So remember, if the log bases match, that means that x squared minus x has to equal 6. So look here, this one, you got an x squared. This thing is quadratic. Since it's quadratic, we need a 0 here. And you ought to make a 0 there. We're going to subtract 6 from both sides. So this will give me an x squared minus the x minus 6. So none of these are like terms, so just put them in order. And that'll equal the right side, which is now a 0. So we get to factor again. So x is an x squared is going to be an x and an x. The last number is negative again, so I'm going to have unlike signs. All right, this time the larger number will be negative like the middle. So y'all check out this. Find me 2 factors of 6 that'll subtract and give me a 1. Ooh, Ella, make those subtract to give me a 1. See, your 6 minus 1 will give me a 5 on that one.
2 and 3.
2 and 3, good job. So the 3 will be negative and the 2 will be positive. See, they got to equal -1 here, okay? All right, -3 and 2 equal -1. 2 times -3 equal -6. All right, y'all. So set each of those equal to 0 and solve. So y'all, we're going to subtract 2 here. I get x is a -2. Here I'm going to add 3 and get x is a +3. All right, Brandon, what's my final answer?
3.
3, good job. So y'all, we cannot keep the 2 again, and we're only going to keep that +3. So y'all, I'm going to do one more of these, and then I'll sort of look at that support real quick. But the support was just doing stuff to get you ready for these equations, okay? All right, so the last one I'm going to do with the logs has a log 3 x plus 12 plus a log 3 x minus 12 all equal to a 4. So nothing I can do on the right side, but y'all look here, you got 2 logarithms, and we're going to rewrite this as a single log. Now they're being added, so it's going to be a product again. So we'll have our log base 3 x plus 12 times x minus 12 all equal to a 4. And y'all, I'm going to go one step further and multiply this out. So you would have to FOIL this. But y'all, this is conjugate pairs. Conjugate pairs, you can shortcut when you FOIL them. just like we learned when we was doing the all that foiling in that 8.4 section, okay? So since they're conjugate pairs, x times x is x squared. 12 times negative 12 is a negative 144. All that equals 4. Y'all, the reason you don't have to FOIL the whole thing out is because x times negative 12 would give you negative 12x. 12 times x in the middle gives you positive 12x. So that 12x and that negative 12x, they're going to cancel out every time. So the FOIL conjugate pairs, first two and then the last two, okay? All right, so this one's a little different than the one I just did. This one only has one log on it. So since there's only one log equal to a number, we're going to rewrite as exponential. So base is 3 raised to an exponent of 4. That's going to equal the x squared minus 144. All right, y'all, let's see. 3 to the fourth power. That'd be what? 3 times 3 times 3 times 3. Ooh, that's a lot of threes. So that equals, looks like 81 on that, right? That's going to equal x squared minus 144. Now, y'all, this one I'm going to solve a little bit different. It's quadratic, but it's missing the x term. So you've got the x squared term and you've got the number. You do not have an x term. So the easiest way to do this one would be to get the x squared by itself and do the square root to it. So to get x squared by itself, I'm going to add 144 to both sides. So let's see, 81 and 144. Oh, that's going to give me what? 225 equal to my x squared. So since it's missing the x term, I'm going to solve it by taking square roots. So now I'm going to take square roots. So y'all, the square root of 225 will equal the square root of x squared. Now remember, since I'm taking the square root of a number, this can be a plus or a negative. Now y'all know the right side will be x. So y'all, what is the square root of 225? It'll be a plus or negative what? So where's Ella with that calculator? What you get? Good job, 15. So this will be a plus or minus 15. So x equals 15 or x equals negative 15. But y'all remember, I'm not keeping this negative answer. So the only answer is going to be a positive 15. All righty, y'all. Questions on those? All right, so y'all, I will stay on your support. Um, it has 5 problems. The first 3 problems are going to be like this one. And it says solve. So the first 3 are going to do the cross multiplying stuff. So this one has an x minus 7 over x plus 1 equals 1/2. So to solve this one, you're going to cross multiply, sort of like I was doing on those problems. So the x minus 7 both get multiplied by 2. So 2 times x is 2x. 2 times -7 is a -14. That's going to equal the other side, which is the x plus 1 times 1. So 1 times x is x. 1 times 1 is a positive 1. All right, also check it out. Move the x's on one side, the numbers to the other. So this one, I'll subtract the x first. So y'all look at that. 2x minus x leaves me 1x minus 14. Those x's cancel, and I get a 1. All right, so it looks like our last step would be, what, add 14 to both sides? So my final answer will be that x equals 1 and 14 is 15. Well, check that out. 15 minus 7 is 8. 15 plus 1 is 16. 8 over 16 will reduce to a 1/2. So these answers will all work on equations if you plug your numbers back into them, okay? So I won't do all of them, but you're going to have 3 where you're going to do cross multiplying, okay? All right, they're going to have one like this one. It says solve. Mine has a v squared minus 9v minus 10 equals 0. So y'all, this one's getting you ready for the ones where I had to factor. So I got a v squared, that'll be a v and a v. Last number is negative, so one of these will be positive, one will be negative. I'm looking for factors of 10, that'll subtract and give me 9. So what y'all think on that? Factors of 10, that'll subtract and give me 9. And I will make the larger one negative like that middle. All right, y'all, got but 2 guesses on that.
Um, you said what was it?
So
Well, I
my,
was gonna say what into you.
I need factors of 10 that'll subtract and give me a 9. Oh, Ellie, you got them, 1 and 10, right? The only other choice was 2 and 5, but notice 10 and 1 give me 9 like I need here. So since the 10's larger, it'll be negative, and the 1 is positive. So y'all remember, anytime the last one's negative, you're going to have unlike signs. And remember, when you add stuff with unlike signs, you subtract and get a sign of the larger number. So that's why I'm finding factors that actually subtract instead of add, okay? All right, and I set both these equal to 0. So here, I would subtract 1. I get v is -1. And then here, add 10. And I get v equals 10. Now remember, this is support, so you can keep both answers, okay? Since this is not a logarithm equation, you got to keep both answers on your support, okay? All right, y'all, then the last one was another solve. Now mine has a 3n squared plus 13n plus 10 equals 0. So this time I got a 3n squared. So that'll be a 3n times an n. So the only factors of 3 are 3 and 1. So you got to make a 3 and a 1 in front. All right, look at this. The last number is positive. When the last number is positive, both of these factors will be positive like the middle. All right, so what I need to do is figure out factors of 10 that I can put in here that'll equal 13. Now you got a 3 here. So let's think. Factors of 10 are going to be 10 and 1. and 2 and 5. So I'm going to start with 10 and 1. Now you would rearrange them, So let's see. Let's try this. 10 and 1. So let's see if the outside and inside will equal 13. So y'all here, 10 times n is 10. 3n times 1. Oh, that works perfect. 10n and 3n equal 13. Now, if I would have had them backwards, I would have switched them and made this a 1 and that a 10. And I'd have seen if I would have had the numbers I needed. If not, I would have started using the 2 and the 5. So this is called trial by error, but it works. So just find the combination that gives you a 13, okay? And you're looking at this 10 here and 3 here. Since those equal 13, I can now make this 3n plus 10 equals 0 and n plus 1 equals 0. Now, if you don't like factoring when they got a number in the front, go to that week 5 and use that quadratic formula calculator. A is 3, B is 13, and C would be 10, okay? Y'all, let's solve this. So let's subtract 10. I get 3n equals a negative 10. And then I'm going to divide by 3. So that cancels, and I get n is a negative 10 thirds. So the quadratic formula calculator would have gave you negative 10 thirds. And then over here, all you had to do was subtract 1 and get a negative 1. So the quadratic formula would have gave you the two final answers, okay? Also, that's the three things you're going to do. There's 3 of them doing cross multiplying, one solving without a number in the front, and probably a negative at the end so that you get unlike signs. And then my last one, they're going to give you one with a number in the front. So either factor it, trial and error like I did, or use the quadratic formula by hand if you want, or use that quadratic formula webpage I gave you, okay? So y'all, either way on that one. All righty, so y'all, what questions y'all got? All right, y'all. So listen, let's see, Tuesday. Tuesday won't be real long. Tuesday, we're going to knock out 9.7, and it deals with continuous compounding interest type questions. So they're not too bad. And that's all we got for that night. And then Thursday, I will study for test 4. So we'll review test 4 on Thursday. And y'all, the next week, that next Tuesday, we're studying for the final exam. Okay? Your final exam is going to open on May the 7th, and it'll be due May the 11th.